Hello, in this lecture we will find out the area of the green circle. In the drawing we have square ABCD. We know that one side of square ABCD equals to 4 units. So AD equals to DC equals to CB equals to AB equals to 4 units. Inside this square we have this circle, and we also know that the radius of this circle equals to 1 unit. So here the radius of the circle equals to 1 unit. So we define the radius of this circle as R, and R equals to 1 unit. And we want to find out the area of this green circle. So first of all, I will present to you a new rule. Rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 1 again. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have a circle, this circle, the center of this circle is at this point. We define the center of the circle as point O, and we also have tangent AB. This tangent AB is tangent to this circle at this point. We'll define this point as point M. The touching point between tangent AB and this circle is defined as point M. Point M, it is actually also the point of tangency of tangent AB with this circle. We will join together points O and M by a straight line. Actually, OM is the radius of this circle. We'll define the radius of this circle as R. And as you can see in the drawing, the radius, this radius OM, it is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So according to rule number 1, a tangent to the circle, that is to say AB, tangent AB, is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius like in this drawing that is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so this is the meaning of rule number 1. Actually, we can implement rule number 1 in our drawing. In our drawing, we will define the center of this circle as point O. We will define the touching point between tangent AD and this circle, this point as point M. Point M is the point of tangency of tangent AD with this circle. And as you can see in the drawing, we have the radius OM. It is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency. Therefore, according to rule number 1, this tangent AD or DA, is perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay? And we also know that all 4 angles inside the square are right angles. So all 4 angles inside square, this square ABCD are right angles. That is to say this angle is a right angle. It is 1 out of 4 angles of square ABCD. Therefore, it is a right angle. It equals to 90 degrees. Here we will define the point of tangency of tangent AB with this circle. We will define this point, the point of tangency, as point N. We will join together points O and N by a straight line. ON is the radius of this circle because of the fact that line segment ON starts from the center of this circle. That is to say, it starts from point O, that is the center of this circle, and ends at point N, that is a point on the circle itself. Therefore, O1 is the radius of this circle. And as you can see in the drawing, we have this radius ON, it is drawn to the point of tangency. That is to say, it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, whenever you have a radius that is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? We will define the point of tangency, this point of tangent EC with this circle as point K. Then we will join together points O and K by a straight line. Actually, OK is the radius of this circle because of the fact that it starts from the center of the circle and ends at point K, that is the point on the circle itself. Therefore, OK is the radius of the circle, that is to say it equals to 1 unit. And again, we have the radius OK, it is drawn to the point of tangency, that is to say it is drawn to point K, that is the point of tangency of tangent CE with this circle. Therefore, according to rule number 1, the radius EC will be perpendicular to this tangent. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And in the next step, I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. I will write it down. The sum of the angles in any quadrilateral is equal to 360 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we will focus on quadrilateral MOAN. In quadrilateral MOAN, according to rule number 2, the sum of its angles equal to 360 degrees. So which angles quadrilateral MOAN has? It has 3 right angles, 1, 2, 3. The sum of 3 right angles is equal to 90 times 3 is 270 degrees, plus the size of the fourth angle that we will define as angle X. So 270 degrees plus the size of angle X. In conclusion, those 4 angles, the sum of those 4 angles must be equal to 360 degrees according to rule number 2. I will repeat again. If you focus on quadrilateral MOAN, this quadrilateral, the sum of its angles must be equal to 360 degrees according to rule number 2. So the sum of 3 angles is 270 degrees plus the size of the fourth angle must be equal to 360 degrees according to rule number 2, this rule. We will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees equals to 90 degrees. So angle X is a right angle, it equals to 90 degrees. So we will replace angle X by a right angle. So as you can see, quadrilateral MOAN, this quadrilateral has 4 right angles, 1, 2, 3, 4. So all of its angles are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square, it must be a rectangle. If not a square. So I'll read rule number 3 again. According to rule number 3, any quadrilateral I'll read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral MOAN has 4 right angles, we will relate to this quadrilateral as a rectangle. Okay, so we will relate to quadrilateral MOAN as a rectangle. Okay, we will relate to quadrilateral MOAN as a rectangle because of the fact that it has 4 right angles, and according to rule number 3, it must be at least a rectangle. Okay. We also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. I will repeat on rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. So if we relate to our rectangle MOAN, according to rule number 4, the opposite sides of rectangle MOAN are equal to each other. It means that MO equals to AN, MO equals to AN, according to rule number 4. So in rectangle MOAN, according to rule number 4, MO must be equal to AN. Okay? But it is given us in the question that MO equals to 1 unit. It is the radius of this circle. So we can write here that MO equals to 1 unit. And from this equality, we will conclude that AN also equals to 1 unit. AN also equals to 1 unit. AN equals to 1 unit. So we can write here that AN equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. MA equals to ON according to the same rule, rule number 4. MA equals to ON according to rule number 4. But we already know that ON equals to 1 unit. It is the radius of this circle. So we can write here that ON equals to 1 unit. So from this equality, we will conclude that MA also equals to 1 unit. MA also equals to 1 unit. So we can write here that MA equals to 1 unit. So actually, as you can see, all 4 sides of rectangle MOAN are equal to each other, and it is also has 4 right angles. And we have rule number 5. According to rule number 5, if a quadrilateral has four right angles and 4 equal sides, then it must be a square. So I will read rule number 5 again. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, then it must be a square. And our quadrilateral MOAN, as you can see, has 4 right angles, 1, 2, 3, 4, and 4 equal sides. All of its sides are equal to 1 unit. Therefore, according to rule number 5, quadrilateral MOAN is a square. According to rule number 5. Okay. repeat again, because of the fact that quadrilateral MOAN has 4 right angles and 4 equal sides, quadrilateral MOAN is a square according to rule number 5. And we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angle of the square, the angles of the square, into 45 degrees angles. So I read rule number 6 again. According to rule number 6, the diagonals of a square bisect the angles of a square of the square into 45 degrees angles. So it means that in our diagonal in our square MOAN, the diagonal OA, this diagonal of square MOAN, this diagonal OA of square MOAN bisects this angle into 2 angles of 45 degrees. This is a right angle and it bisects it to 2 angles of 45 degrees. That is to say, this angle will be equal to 45 degrees and this angle will be also equal to 45 degrees according to rule number 6. So that is to say, angle OAN equals to 45 degrees according to rule number 6. But because of the fact that point N is located on side AB of the square, we can relate to this angle that equals to 45 degrees as angle AOB, because of the fact that all 4 points A, N, and B are located on the same straight line. Therefore, it doesn't matter at all if we relate to this angle that equals to 45 degrees as angle OAN or angle OAB. It will not change anything, only the size of the length of one leg of this angle that equals to 45 degrees, but the angle will still remains angle of 45 degrees. Okay, if you extend one leg or even 2 legs of any angle, it will not change the size of the angle. It will still remain the same angle as it was before you extended the legs of the angle. You can see it as we extended the length of the leg of this angle from AN to AB. Therefore, it will still remain angle that equals to 45 degrees. So we can write down that angle OAB equals to 45 degrees according to rule number 6. Okay, so angle OAB equals to 45 degrees according to rule number 6. We'll repeat again. Angle OAB equals to 45 degrees according to rule number 6. Likewise, the diagonal CA so if we relate to the big square ABCD, then according to rule number 6, its diagonal CA, bisects this angle into angles of 45 degrees. That is to say, this angle will be equal to 45 degrees and this angle will be also equal to 45 degrees. That is to say, angle CAB also equals to 45 degrees according to rule number 6. So angle CAB also equals to 45 degrees according to rule number 6. So actually we have here two angles, angle OAB and angle CAB. They are both equal to 45 degrees, therefore they are equal to each other. So we can write down that angle OAB equals to angle CAB. And from the fact that this angle OAB equals to angle CAB, we will conclude that the diagonal CA or AC passes through point O. Okay? We will conclude that the diagonal AC of square ABCD passes through point O. Okay, the diagonal, because of the fact that angle CAB equals to angle OAB, we will conclude that the diagonal AC of square ABCD passes from point O. Okay, we know that angle OAB equals to angle CAB. Because of the fact that those two angles are equal to each other, the diagonal CA of square ABCD must pass through point O. Otherwise, if the diagonal CA doesn't pass through point O, then they cannot be equal to each other. Angle CAB will never be equal to angle OAB. Okay? The only possibility that angle CAB will be equal to angle OAB is that the diagonal CA will pass to point O, otherwise if the diagonal CA doesn't pass for point O, then angle CAB will not be equal to angle OAB, but because of the fact that they are equal to each other, we will conclude that the diagonal CA passes for point O. Okay? In the next step, I will present to you a new rule, rule number 7. According to rule number 7, the length of the diagonal of a square that has a side or that a side of that the length of its side equals to S units will be equal to square root of 2 multiplied by S. I'll repeat again on rule number 7. According to rule number 7, the length of the diagonal of a square that the length of its side again, the length of the diagonal of a square that the length of its side equals to S units will be equal to square root of 2 multiplied by S. I will repeat again on rule number 7. According to rule number 7, the length of the diagonal of a square that the length of its side equals to s units will be equal to square root of 2 multiplied by s. So what is the meaningful number 8? The meaningful number 8 is if we have diagonal ABCD, if we have a square ABCD, we know that in square ABCD, this square the length of one side of this square ABCD is s units. So AB equals to s units, BD equals to s units in its length, CD equals to s units in its length, and AC also equals to s units in its length. Then if we know that one side of a square is equal to s units in its length, then according to rule number 7, the length of its diagonal BC or AD, it doesn't matter, BC will be equal to square root of 2 times s. Okay, if we know that the length of one side of a square is equal to s units, then the length of its diagonal BC or AD, will be equal to s times square root of 2 units. So square root of 2 units, square root of 2 times s units. Okay, that is the meaning of rule number 7. And we can implement rule number 7 in our drawing. We have square MOAN. We will calculate the length of diagonal OA of this square. The length of diagonal OA, according to rule number 7, will be equal to the length of a side that is 1 unit times square root of 2. According to rule number 7, the length of diagonal OA in square MOAN the length of diagonal OA in square MOAN equals to the length of its side that is 1 unit times square root of 2. 1 times square root of 2 equals to square root of 2 units. So we found out that OA equals to square root of 2 units. Likewise in square ABCD, the length of diagonal AC or CA will be equal to the length of one side of square ABCD. It is given us that the length of one side of square ABCD equals to 4 units. So it is 4 times square root of 2 units. Okay, we found out that CA equals to 4 times square root of 2 units and OA equals to square root of 2 units. So we can write here that OA, the diagonal OA of square MOAN equals to square root of 2 units, and the length of diagonal CA of square ABCD equals to 4 times square root of 2 units. And what is the value of CO? The value of line segment CO is equal to CA minus AO. Again, CA minus OA equals to CO. I'll write it down. CA minus OA equals to CO. You can see it from the drawing. CA minus OA equals to CO. So CO equals to CA. We have already found out that CA equals to 4 times square root of 2 units. Minus OA. We have already found out that OA equals to square root of 2 units. And 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. So in conclusion, we found out that CO equals to 3 times square root of 2 units. So we can write here that CO, this line segment CO equals to 3 times square root of 2 units. So in the next step, we will focus on the right triangle, triangle COK. We'll focus on the blue right triangle, triangle COK. Okay? In the blue right triangle, triangle COK, according to the Pythagoras theorem, in the right triangle, triangle COK, right blue triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle COK is the side that is in front of the angle that is 90 degrees. So it is CO. And the square of the hypotenuse is CO square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square. I will repeat again. In the right triangle, triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CO, so the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square. Okay? And what is the value of CO? We have already found out that CO equals to 3 times square root of 2 units. So CO square will be equal to 3 times square root of 2 units square. And it equals to OK square. OK equals to 1. It is the radius of the circle. So OK square is 1 square. 1 square is 1 plus CK square. CK square is the missing variable, so we will leave it as it is. So in total we found out, in conclusion we found out that 3 times square root of 2 square equals to 1 plus CK square. 3 times square root of 2 square is 9 times 2, so I'll write it down. So 9 times 2 equals to 1 plus ck squared. 9 times 2 is 18, so I write it down. 18 equals to 1 plus ck squared. Here we will subtract 1 from this equation number 1, and we get that 18 minus 1 is 17. 17 equals to ck squared. Here we'll take a root out of this equation number 1, and we will get that ck, according to equation number 1, ck equals to the square root of 17 units. ck equals to the square root of 17 units. So we can write here that ck equals to square root of 17 units, and in the next step here you can see that ck equals to square root of 17 units. Okay, in the next step I will present to you a new rule, the last rule, rule number 8. Rule number 8 states that the lengths of two tangents from a common external point to a circle are equal. Okay, so I will read rule number 8 again. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have a circle and we have also an external point of this circle, this point P is an external point of this circle. Why point P is an external point of this circle? Because of the fact that point P is not located inside this angle, nor on this angle, nor on this. Point P is an external point of this circle because of the fact that point P is not located inside this circle, nor on this circle, but it is located outside this circle. Therefore, this is defined as an external point of this circle. So if from the external point, point P, we will draw two tangents to this circle, this will be the first tangent, and we will define the point of tangency of the first tangent with this circle as point A. And we will also draw a second tangent to this circle from point P. We will define the touching point, or the point of tangency of the second tangent with this circle as point B. So the length of the first tangent is AP, and the length of the second tangent is BP, and according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So the length of two tangents from a common external point, point P, to a circle, that is to say PA and PB, the length of those two tangents are equal to each other, that is to say AP equals to BP. Okay, so whenever you draw two tangents to a circle from a common point, common external point of that circle, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. Okay? So we can implement rule number 8 in our drawing. In our drawing we have the external point, point E. Point E is an external point of this circle. And from point E, we have two tangents to this circle. The first tangent is EN. The second tangent to this circle is EK. And according to rule number 8, whenever you draw two tangents to a circle from an external point of that circle, like in this drawing, from point E we have two tangents to this circle, then the length of those two tangents will be equal to each other, that is to say EN equals to EK. Okay, so according to rule number 8, EN equals to EK, and if we define EN as X, if EN equals to X, then from this equality we will get that EK also equals to X, EK also equals to X. So here we can write down that EN equals to EN or NE equals to X units, and EK also equals to X units. And in the next step, we'll calculate the length of line segment EB, side EB or line segment EB. As you can see from the drawing, line segment EB equals to AB minus AN minus NE. I'll repeat again. BE equals to AB minus AN minus NE. Very simple. I'll repeat again. Side EB equals to AB minus AN minus NE. Okay, so EB equals to AB equals to 4 units. It is the length of one side of square ABCD that equals to 4 units. Minus AN, we have already found out that AN equals to 1 unit. Minus NE. NE equals to X units. X units, so in conclusion, we found out that BE equals to 4 minus 1 minus X. 4 minus 1 is 3. So in conclusion, we found out that EB equals to 3 minus X. So we can write here that EB equals to 3 minus X. And we also know that BC is one side of square ABCD, therefore it equals to 4 units. It is given us the question. And we've already found out that EC equals to square root of 17 units plus X. Okay, so, and we know that all four angles of square ABCD are right angles, and this angle is one out of four angles of square ABC, therefore it is a right angle, it equals to 90 degrees. All the angles of square ABCD are right angles. So if this is a right angle, then the green triangle, triangle CBE, is a right triangle. So we focus on the right green triangle, triangle CBE. On the right green triangle, triangle CBE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right green triangle, it is actually CE. CE is the hypotenuse, so the square of the hypotenuse is CE squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CB square or BC square plus EB square. I will repeat again. In the right green triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CE square equals to BC square plus EB square. We have already found out that CE equals to square root of 17 plus x. Therefore, CE square will be equal to square root of 17 plus x square, and it equals to BC square. BC equals to 4 units, therefore BC square equals to 4 square. 4 square is 16, plus EB square. EB equals to 3 minus x, therefore EB square will be equal to 3 minus x square. So in conclusion, we found out that square root of 17 plus x square equals to 16 plus 3 minus x square. Here we will open the brackets in both sides of equation number 2, and we will get that square root of 17 plus x square equals to 17 plus x square plus 2 times square root of 17 x, and it equals to 16 plus 3 minus x square is 9 plus x square minus 6x. Okay, so here we have x square in both sides of equation number 2, so x square will get cancelled. And here 16 plus 9 is 25, so I write it down. 25 minus 6x equals to 17 plus 2 times square root of 17 x. Here we will subtract from this equation number 2, 17, and we will get that 17 minus 17 is 0, so here what is left is only 2 times square root of 17x, and it equals to 25 minus 17 is 8, minus 6x. So here we will divide this equation number 2 by 2, and we will get 2 over 2 is 1, so we left only with square root of 17x, that equals to 8 over 2 is 4, minus 6x over 2 is minus 3x. So here we will add to this equation number 2, 3x, and we will get that square root of 17x plus 3x equals to 4. So here we got that square root of 17 plus 3x equals to 4. Here we will take, this is actually square root of 17x, I forgot the x. So here we will take a common factor, we will take out a common factor x out of these expressions, and we will get that, so x is a common factor, and what is left from square root of 17x after we took x as a common factor? What is left, it is actually square root of 17, and what is left from 3x after we took x as a common factor from it, what is left, it is actually 3, and it equals to 4. Here we will divide this equation number 2 by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3. So here we found out the value of x. We will multiply this side of the equality by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3 in order to get rid from the square root of 17. We don't like to have square root in the denominator, so we will get rid of it. So x equals to 4 times, we will multiply it by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3. So we change nothing, and it is divided by square root of 17 plus 3. So in conclusion, we have this expression. So what is the value of square root of 17 plus 3 times square root of 17 minus 3? We will find out the value of this expression according to the algebraic identity, that a plus b times a minus b equals to a squared minus b squared. In our specific case, we have a equals to square root of 17 and b equals to 3. Therefore, we will get that a square is square root of 17 square is 17, minus b square, it is minus 3 square is 9. That is what we have in the denominator, and in the numerator we didn't change anything in the numerator, so we will copy it as it is. It will be 4 times square root of 17 minus 3. So we got that x equals to 4 times square root of 17 minus 3 over 17 minus 9. 17 minus 9 is 8, so I write it down. So x equals to 4 times square root of 17 minus 3. 17 minus 9 is 8. So in conclusion, we found out that x equals to 4 times square root of 17 minus 3 over 8. This is the value of x, according to equation number 2. And what is the area of the green right triangle, triangle CBE? The general formula for the area of any triangle, this is the sign of the area. It means the area of the triangle. Actually, it equals to the base of the triangle times the height to the base over 2. Okay, so we will implement this formula in our green right triangle. The base is EB, so the area of triangle EBC, I'll repeat again, this is the sign of the area. It means the area of triangle EBC equals to the base, that is EB, times the height to the base. The height must create 90 degrees with the base, and indeed BC creates 90 degrees with the base. Therefore BC is the height, and BC, so we write down BC, that is the height, over 2. Okay? So the area of triangle EBC will be equation number 3, according to equation number 3, will be equal to EB. EB is 3 minus x, and times BC. BC equals to 4 units. This times 4 over 2. Okay, so in conclusion, we found out that the area of the green right triangle, according to equation number 3, equals to 3 minus x times 4 over 2. 4 over 2 is 2. So we get that the area of the green right triangle, triangle EBC, according to equation number 3, is equal to 2 times 3 minus x. So we have already found out that x equals to square root of 17 minus 3 over 2. This is the value of x according to equation number 2. So here we will place the value of x from equation number 2, this equation, inside x in equation number 3, this equation, and we will get that the area of the green right triangle, triangle ABC, is equal to 2 times 3 minus x, and x equals to square root of 17 minus 3 over 2. So here we will multiply 3 by 2 and then we will divide it by 2 in order to have a common factor with this expression, and we will get that this is actually equation number 3. According to equation number 3, the area of the green right triangle, triangle EBC equals to 2 times 3 times 2 is 6 over 2 minus square root of 17 minus 3 so the area of the green right triangle, triangle EBC equals to, according to equation number 3, it equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled. And what is left from equation number 3 after we cancel 2? What is left is actually the area of the green right triangle, triangle ABC according to equation number 3 equals to 6 minus square root of 17 minus 3. Okay, so we will open the brackets here and we will get that the area of the right green triangle, triangle EBC according to equation number 3 equals to 6 minus square root of 17 minus 3 is plus 3. So in conclusion, we got that the area of the green right triangle, triangle EBC equals to 6 plus 3 is 9 minus square root of 17 square units. Okay, so we found out that the area of the green right triangle, triangle EBC equals to 9 minus square root of 17 square units, or in terms of numbers, it equals to 4.88 square units. Okay, I'll repeat again. The area of the green right triangle, triangle EBC equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle, triangle EBC equals to 4.88 square units. I will repeat again. The area of this green right triangle, triangle EBC equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle equals to 4.88 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green right triangle ABC. We have here square ABCD. One side of square ABCD equals to 4 units. Inside this square we have a circle. The radius of this circle equals to 1 unit. And we want to find out the area of the green triangle, triangle EBC. First of all, I presented to you rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we have tangent AB is tangent to this circle is point M. Point M is the point of tangency of tangent AB with this circle. And if we have this radius, the radius OM, it is drawn to the point of tangency. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So whenever you have a radius, like in this drawing, radius OM, it is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle. Then the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. This is rule number 1. We implemented rule number 1 in our drawing. We have this radius OM, it is drawn to the point of tangency. Therefore, the tangent AD will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. We also know that all 4 angles inside a square are right angles, therefore this angle equals to 90 degrees. And we also have this radius, ON, it is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we connected together points O and K by a straight line. This is the radius that is drawn to the point of tangency. That is to say, it is drawn to point K, that is the point of tangency E with this circle. Therefore, the tangent EC is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then I presented to you also rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. We focused on quadrilateral MOAN. In quadrilateral MOAN, according to rule number 2, the sum of its angles is equal to 360 degrees. Quadrilateral MOAN has 3 right angles. The sum of those 3 right angles is 270 degrees plus the size of the 4 angles that we defined as angle X. The sum of those 4 angles must be equal to 360 degrees. This is to say 270 degrees plus x must be equal to 360 degrees according to rule number 2. We subtracted 270 degrees from this equality and we got that the size of angle x is equal to 90 degrees. That is to say angle x equals to 90 degrees. This angle is a right angle. Okay, so actually quadrilateral MOAN has 4 right angles. And we have also rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral MOAN has 4 right angles, we will relate to it as a rectangle. And we also have rule number 4 that states that the opposite sides of a rectangle are equal to each other. So the opposite sides in rectangle MOAN are equal to each other according to rule number 3. According to rule number 4, the opposite sides of rectangle MOAN are equal to each other. That is to say, MO equals to AN, MO equals to AN. But we know it is giving us the question that MO equals to 1. MO equals to 1. So from this equality we will derive that AN also equals to 1. AN equals to 1. Likewise, MA equals to ON. MA equals to ON. But we already found out that ON equals to 1 unit. So from this equality we will derive that AM also equals to 1. AM also equals to 1. So we found out that all 4 sides of quadrilateral MOAN are equal to each other. They are all equal to 1 unit. And we also found out that all angles in rectangle MOAN are right angles. So we have also rule number 5. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, then it must be a square. And quadrilateral MOAN has 4 right angles and 4 equal sides, therefore quadrilateral MOAN is a square according to rule number 5. Okay, and we also have rule number 6. According to rule number 6, the diagonals of a square, the diagonals of a square bisects the angles of the square into 45 degrees angles. So we know that quadrilateral MOAN is a square, therefore its diagonal OA bisects this angle, angle A, to 2 angles of 45 degrees. That is to say, this angle equals to 45 degrees, and also angle OAB equals to 45 degrees. Likewise, so actually angle OAB equals to 45 degrees according to rule number 6. Likewise, in square ABCD, the big square, diagonal CA bisects this angle into 2 angles of 45 degrees. That is to say, angle CAB also equals to 45 degrees according to rule number 6. Angle CAB also equals to 45 degrees. So we have 2 angles that are both equal to 45 degrees, therefore they are equal to each other. That is to say, angle OAB equals to angle CAB. Angle OAB equals to angle CAB. And because of the fact that those 2 angles are equal to each other, we will conclude that the diagonal AC of square ABCD passes through point O. The diagonal AC or CA passes through point O. Otherwise, it must pass through point O, otherwise angle CAB will never be equal to angle OAB. Okay, and then we have also rule number 7. According to rule number 7, the length of the diagonal of a square that the length of its side equals to S units will be equal to square root of 2 multiplied by S. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD and we know that the length of one side equals to S units, then the length of the diagonal BC and also diagonal AD will be equal to S times square root of 2 units. We will use this rule in order to find out the value of OA. That is the diagonal of the small square, square MOAN. It will be equal to the length of each side, that is 1 unit, times square root of 2. So we found out that OA equals to square root of 2 units. And likewise, we found out the length of diagonal CA square ABCD. It will be equal, according to rule number 7, to the length of each side, that is 4 units, times square root of 2. So we found out that CA equals to 4 times square root of 2 units, and OA equals to square root of 2 units. And what is the value of CO? CO equals to CA minus AO. CO equals to CA minus OA. That is to say, CO equals to 4 times square root of 2 minus square root of 2 That is to say, CO equals to 3 times square root of 2 units. CO equals to square root of 2 units. Then, so CO equals to square root of 2 units. Then we focused on the right triangle, the blue right triangle COK. We implemented the Pythagoras theorem in the right blue triangle COK. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse is CO, therefore the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square. We have already found out that CO equals to 3 times square root of 2 units, therefore CO square will be equal to 3 times square root of 2 square. KO equals to 1, so KO square is 1 square is 1, plus CK square. 3 times square root of 2 square is 9 times 2. It equals to 1 plus CK. 9 times 2 is 18. 18 equals to 1 plus CK square. We subtracted 1 from this equality. Equation number 1. 18 minus 1 is 17. So we found out that 17 equals to CK square. We took a root out of this equation number 1, and we got that CK equals to square root of 17 units. So here CK equals to square root of 17 units. Then I presented to you rule number 8. Rule number 8 states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have this circle and we have the external point P, and from point P we will draw two tangents to this circle, then the length of those two tangents will be equal to each other. That is to say, AP will be equal to PB. We implemented rule number 8 in our drawing, because in our drawing we have the external point E, and from this external point E we have two tangents, tangent EN and tangent EK, and according to rule number 8 they are equal to each other. That is to say, EN equals to EK. EN equals to EK according to rule number 8. We defined EN as X, therefore EK will be also equal to X according to this equality. So EN equals to X, EK equals to X. And then we found out the value of line segment EB. EB actually equals to AB minus AN minus EN. EB equals to AB minus AN minus NE. So AB equals to 4, AN equals to 1, and NE equals to X according to our definition. So in conclusion, we found out that EB equals to 4 minus 1 minus X, that is to say it equals to 3 minus X. So EB equals to 3 minus X, and we know that BC equals to 4 units. It is one side of square ABCD that its side is equal to 4 units. EB equals to 3 minus X, and CE equals to square root of 17 plus X. So we focus on, and we know that this green triangle is a right triangle because of the fact that this angle is a right angle. It is 1 out of 4 angles of square ABCD, and all the angles inside the square are right angles, therefore it is a right angle. So we focused on the right triangle CEB, and we implemented the Pythagoras theorem in the right triangle CEB. The right green triangle CEB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CE, therefore the square of the hypotenuse is CE square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BC square plus BE square. CE equals to square root of 17 plus X, so CE square equals to square root of 17 plus X square. BC equals to 4, so BC square is 4 square, 4 square is 16. BE equals to 3 minus X, so BE square equals to 3 minus X square. We open the brackets on both sides of this equation number 2. Square root of 17 plus X square equals to 17 plus X square plus 2 times square root of 17X, and 3 minus X equals to 16 plus 9 plus X square. And we have also minus 6X. So here we have X square on both sides of the equation number 2, so X square will get cancelled. And we also know that 16 plus 9 is 25, so in conclusion we got that 17 plus 2 times square root of 17x equals to 25 minus 6x. We subtracted 17 from this equation number 2. So here 17 minus 17 is 0, so what is left is 2 times square root of 17x. 25 minus 17 is 8. So in conclusion, we got that 2 times square root of 17x equals to 8 minus 6x. We divided this equation by 2, and we got that square root of 17x equals to 4 minus 3x. Then so we got we added actually 3x to this equation number 2, and we got that square root of 17x plus 3x equals to 4. Then we took out a common factor x from these two expressions, and we got that x times square root of 17 plus 3 equals to 4. We divided this equation by square root of 17 plus 3, and we got that x equals to 4 over square root of 17 plus 3. Then we multiplied this side of the equality by square root of 17, and then we divided by square root of 17 minus 3, and we got that x equals to 3 times square root of 17 minus 3 over 17 minus 9, according to the equality that a plus b times a minus b equals to a square minus b square. So in conclusion, we got that x equals to 4 times square root of 17 minus 3 over 8. Actually, we divided this equality by 4, and what is left from this equation is that x equals to square root of 17 minus 3 over 2, because 8 over 4 is 2. Then we have the formula for the area of any triangle. It is equal to the base of the triangle times the height of the base over 2. The base of the green triangle is EB. The height is BC, so it is actually EB times BC over 2. And what is the value of EB? EB equals to 3 minus x. And what is the value of BC? BC equals to 4. So in conclusion, we got that the area of the green triangle EBC equals to 3 minus x times 4 over 2. 4 over 2 is 2. So in conclusion, we got that the area of the green triangle EBC equals to 2 times 3 minus x. And we already found out that x equals to square root of 17 minus 3 over 2 according to equation number 2. So we place the value of x inside x in this equation number 3. And we got that the area of the green triangle EBC equals to 2 times 3 minus, this is the value of x. Then here we multiplied 3 by 2, and then we divided by 2 in order to have a common factor with this expression. And in conclusion, we got that the area of the green triangle EBC equals to 2 times 6 minus square root of 17 minus 3 over 2. 2 over 2 is 1, so 2 will get cancelled, and we found that the area of the green triangle EBC equals to 6 minus square root of 17 minus 3. Here we open the brackets here of this expression, and we got that the area of the green triangle EBC equals to 6 plus 3 minus square root of 17, and the area of the green triangle EBC equals to 6 plus 3 is 9 minus square root of 17. So in conclusion, we found out that the area of the green triangle EBC equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of the green triangle EBC equals to 4.88 square units. I will repeat again. The area of this green triangle EBC equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of this green triangle equals to 4.88 square units. Okay, thank you very much.